Okay, in this video we're going to finish off 1-6, the transformations of functions. And today we're going to start with vertical stretching and shrinking. And in the last video I did mention the order of operations for these transformations of functions. High school RV, horizontal left and right shifts first. Stretching and shrinking will be the second thing we do, and then reflections if there are any, and then our vertical up and down shifts. Well, I'm not going to read all that wall of text. You got that in your book, or you can pause the video and read it. Let's just look at the graph here. In black ink is our x squared graph. And remember, that's you could write it as like this: f of x is x squared, or y equals x squared. Now here, if we put a 2 in front of the x squared, it's like putting a 2 here, and we have just doubled all our y values. So the y value that here was at 1, 1 has been doubled up to 1, 2. And the y value at 2, 4 would get doubled up to 8. So if we put a 2 out front of this, it's the same thing as putting a 2 in front of this. So if we put a 2 here, we're doubling our y values. If we put a fraction there, 1/2 x squared, we would cut our y values in half. Ooh, and I guess that graph is right there. All y values would just be cut in half. X values would not change, just the y values. So here it is described in the book. Let f be a function, c is a positive number, and I'm just going to copy this at the bottom. They have y equals that some number c times f of x. Now if this c value is greater than 1, the graph will be stretched out. You multiply all the y coordinates by the c value. If c is a number between 0 and 1, if it's a fraction, that means your graph is going to be vertically shrunk. You'll also multiply the y coordinates by whatever that c value is. So if c here is a whole number, it will stretch the graph up. If c is a fraction, it will shrink the graph down. Yeah, if it's greater than 1, it will stretch. If it's less than 1, it will shrink it. And what's this great question? Does vertical stretching or shrinking change the graph's shape? Yeah, this will now change the shape. The up, down, and left, right shifts did not affect the shape like the curvature of the parabola. But these vertical stretching and shrinking will change the shape of the graph. So let's try an easy one out here. X cubed, let's see, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. And we could also do the negatives. Negative 1 cubed, negative 1. Negative 2 cubed is negative 8. So if I connect those dots with this red ink, it looks a little something like this. And now for the second graph, it says 1/2 x cubed. So all the y values are going to be multiplied by 1/2, or the y values will be cut in half. So 0, half of 0 is 0. Here, this point 1, 1 will now be over 1 up 1/2. Oh, come on. And next we went over 2 and up 8. Now we're going to cut that y value in half, so we're going to go over 2 up 4. And let's see here if we can squeeze 3 in now. 3 cubed would be 27. Half of that now is still more than 8. So that's as far as points we can graph. It'll look like that. And this will also be reflected around the origin down here. So we went over negative 1 down 1. Now it's just negative 1 down 1/2. Negative 2 down 4. So these y values got pulled down, pulled closer to the x-axis. Let's put it that way. These ones got pulled down, these other ones got pulled up, but all the y values got closer to the y-axis because we multiplied by that fraction. Now a horizontal stretching and shrinking. It's also possible to shrink the graphs horizontally. So let f be a function, c is a positive real number. Now notice, before we had the multiplier outside the f of x. Now it's back inside theirs, f of c times x. It's the same as graph of f of x, but horizontally shrunk. You divide the x coordinates by c. So whatever number is in there in front of that x, you're going to divide the x coordinates by that number. If c is a fraction between 0 and 1, it's going to horizontally stretch out. So down to the graphs here, if c is a positive number, f of x is the blue one. If it is a positive number, you're dividing your x coordinates like that, so everything got closer to the y-axis. This got stretched back. This part out here in blue got pulled in closer. And when we did the other one, everything got pulled toward the x-axis. Now we're getting pulled toward the y-axis. But if it is a fraction, that is going to sort of stretch us out. Again, here in blue is the original f of x. If it's a fraction, it's going to push us away from the y-axis. How does horizontal shrinking or stretching change the graph shape? A horizontal shrink compresses the function's graph toward the y-axis. A horizontal stretch moves the graph away from the y-axis. When I wonder, let me see if I can pull this off with my Mimeo. If I just do that, there's the original graph, and we just stretch it out. Oh, there we go. Okay, now in this example, we don't have a function that we can come up with the points on our own. They just gave us this odd function, but they were nice and they labeled some points there for us. Okay, and here, all we really need is this function notation here. For this one, f of 2 times x. Remember, this means we are going to divide the x coordinate by whatever that number is. So we have our original f of x graph. We'll look at the x coordinates and divide the x coordinates in half. So looking at this x coordinate, -4, we're going to cut that to -2. It's going to have the same y value. It'll still be, that's terrible, right on the x-axis. So this x coordinate got cut in two. Now it's -2, 0. Up here, we had this -2, 4, cut the x value in half. Now it's -1, 4. This x value at 0, right at the origin, half of 0 is 0. So this looped part of the graph kind of looks like a parabola. We can draw that now. It's been pushed toward the y-axis. This point here, 2, -2, we're just going to cut the x value in half. Now it's 1, -2. And then here's a point right on the x-axis, 2, 0. That'll be 4, 0. We'll cut that in half to 2, 0. So again, that whole number, this being a whole number, pushed us toward the y-axis. We cut all our x values in half and everything got scrunched up. So now it looks a little more something like this if I draw it right on top. Oops, there we go. All these points got pushed closer to the y-axis. Now here I'm going to switch to the next slide. We're going to do it with a fraction. So again, here are these points. And I should have made my graph a little bigger. Okay, I guess we can pull this off. I'll move this here. That'll work. So we are going to divide the exponents by a half, or the x values by a half. So if we have some number and we're going to divide it by a half, that means we invert and multiply. So we're basically just going to multiply our x coordinates by 2. This -4, 0 would now be -8, 0. 5, 6, 7, 8. So here's -8, 0. I'd have a point there. This -2, 4 would be -4, 4. -4 up to 4. And then we would have the origin. Half of 0 is still 0, so we'd put that there. So now the looped part got pushed away from the y-axis. This part here got pushed out that way, stretched out. So here we're going to again double our x value. So this 2, -2 is now 4, -2 over 4 down to -2. And then here 4, 0 would be 8, 0, 5, 6, 7, 8, 0. So this part that looks like a V, those straight line segments, this got stretched out to 8. And again, remember the order of operations. High school RV, horizontal first, stretches and shrinks, any reflections over an axis, and then your vertical, up or down. So here's a couple of practice problems for us. Let's start with the absolute of x. That starts at the origin. Absolute of 1 is 1, 2 is 2. So we can take that all the way out to 6, 6. And then the absolute values make all the negatives into positives, so we'll have that also reflected here into quadrant 2. Now here is, again, if I can write that as y equals the absolute of x, if I put a 2 here, I'm doubling all my y coordinates. So instead of going over 1 up 1, I'm going to go over 1 up 2. And instead of going over 2 up 2, I'm going to go over 2 up 4. And then over 3 up 6. So it's still going to be a V shape, but it's going to be a steeper V. Putting the 2 there moved everything closer to the y-axis. If that was a fraction, everything would have got moved away. Ooh, and I can just do that right here. Here is our 2v. And if I did a half, it would be outside the original function, the original graph. Okay. Oh, no, this is another one. We just have some points here. They want us to move these points around. So I'll just do it on one graph and then erase. Let me do this. Okay, for the first one, part A, remember the 2 in front of the x means we are going to divide all x coordinates by 2. So here we had negative 2, 0, divide that x coordinate by 2, so that would be negative 1, 0. This x coordinate 0, cut that in half, it's still 0, so that'll still be 0, 3. And then here, cut this x coordinate in half, that'll now be 1, 0. Here, this will now be a 2, negative 3. And then this 6, 0 will be cut down to a 3, 0. So if I connect my dots, it looks like that. A whole number there moved everything closer to the y-axis. Now, if we do the reverse and not cut our x values in half, we're going to divide our x values by a half or multiply them by 2. So this x coordinate is now a negative 4, 0. 0, 3 is still 0, 3. This point 2, 0 is now 4, 0. This will be 8, negative 3. 8, negative 3. We're going to have to go off the graph here a little bit. This would be 12, 0. So 8, 9, 10, 11, right about at the edge of the slide. And our graph now looks like this. It's been pushed away from the y-axis. Everything got stretched out by the fraction in front of that variable. Now, a function involving more than one transformation is graphed by performing the transformations in the following order: horizontal shifting, stretching or shrink, reflecting, vertical shifting. High school RV. And let's see here, just do a little notation here. The horizontal shifting, that you're going to have f of x plus or minus. So you'll have an x plus or minus something in there with the x variable in the parenthesis. The stretching and shrinking is going to be f of, you're going to have a number in front of your x. Fraction or whole number will determine if it stretches or shrinks. The reflections, remember that's the negatives, either the negative of f of x or the f of negative x. One is a flip over the x-axis, the other is a flip over the y-axis. And then finally the vertical shifting is when you have your f of x and then the plus or minus occurs outside. That's the one that is intuitive. Plus is up, down is negative. Okay, so let me get a little more room here. Move this up. Oh, I still want to see our function. So here is f of x. F of x is this. We got our, it looks pretty familiar. We got our, like, kind of like a parabola here in a little V shape. And I guess, hold on a minute here. Yeah, and this is just how we're going to transform it. The blue graph down here is f of x, and then we're going to do negative a half of f of quantity x minus 1, and then the plus 3 after the fact. And what I'm going to do here, I'm just going to enlarge two of these graphs. And then as we do a transformation, I'll graph it and we can just bounce back and forth. And I'll erase the opposite one as we go through. So let's see here. We start again, high school RV, horizontal. Do we have a horizontal shift? It is right here. That means we're going to move everything 1 unit to the right. So we're going to add 1 to each x value. So this -40 is now -30. -24 is now -14. Let's see, 0, has been shifted over to 0, 1. This will be 3, -2. And then we'll have 5, 0 right on the x-axis. So there's our parabola has been shifted over. Now it crosses over the y-axis, and then we have our little V shape. So we did our horizontal shift first. Next will be stretching and shrinking. And that we have right here, the 1/2. And I should have wrote this. So that would have been f of x minus 1. And now we're going to do the 1/2. So 1/2 of f of x minus 1. And let me switch over to blue ink. We're going to cut all the y values in half. So the x-intercepts will stay the same because half of 0 is still 0. So these 3 x-intercepts will be the same, but our y values are now cut down. This 1, 4 is now 1, 2. So there's our little parabolic arch. And then this 3, -2 is now 3, -1. That little V shape got a little closer to the y-axis, or excuse me, to the x-axis. Okay, now I'll bounce back here to the left. Let me erase this. Next up, high school R is any reflection. And we do have a reflection out here. That means we're going to flip over the x-axis over x, because when we negate this, it's like negating our y values. So that means everything is going to flip over the x-axis. So the x-intercepts will be the same at 3, -3, 1, and 5. But now this peak here that was at -1, 2 will now be -1, -2. So the parabola, the arch, sort of goes here under the x-axis. And then this point, 3, -1, is now 3, +1. That's been bumped up into the first quadrant. So there's our reflection. One more to go. We now have our last high school RV, vertical shift. That's occurring out here. It's a plus. So we're going to move all of our points up 3. So here we had a -3, 0 x-intercept. That's now up here. The same thing is going to occur above 1 and above the 5, because here was our old x-intercepts, the x-axis, those 3 points hitting it. Though all 3 of those points got shifted up the same. This point here at -2 is now going to be up at +1, so there's our parabolic arch shape. And this point here at 3, 1 also got shifted up 3. Now it's at 3, 4. And there's our little V shape. And there's our multiple transformations. And is there another example? No, it looks like a Huddle problem here. Try this one out. Here is f of x.
What kind of place is this?
No, these are just extra graphs for that last example. Yeah, I just didn't use them. I just erased and kept bouncing back and forth. So here is another example. Example 9. We have our f of x's x squared graph, and they provided that for us 0, 0, 2, 4, and 1, 1, and -1, 1 would be some points on there. And they want us to graph that into 2 times quantity x plus 3 squared and -1. So maybe what I'll do, try to do this all on this graph. So let's see, high school RV. First, we want to find any left-right shift here. It's a +3, so that's going to move us 3 to the left. So now we're going to be here at -3, and again, from the origin, you could go over 1, up 1. So I know these 2 will be points at the bottom of my parabola. And then from that point, I would go over 1, up 3 more. So I could go over 1, up 3. Over 1, up 3. So it's going to look something like this. So they're left, right, give me right over here. Horizontal first, stretches and shrinks. Here is a 2 out front of this. So that is our out front of the function. So that's like doubling our y values. All y values will now double. And I should have, I'll do it like this. So all the y values are going to double. Negative 3, 0 is still going to be on the x, or the x-axis, because the y value of 0, double that will be nothing. But instead of going over 1, up 1, I'm going to go over 1, up 2 to get to those next couple points. And then from there, instead of going, well, these next points are up at a height of 4, so now they'll be at a height of 8. All of those have doubled. Up here to 8. So the parabola here, it's kind of wide as we got up higher. Now it's a little thinner. It got shrunk up by that 2 out front. So we did our stretch, high school R. Next is a reflection. Do we have any reflections here? Doesn't look like it. There's no negative in the parenthesis, no negative outside, so no reflections. And then lastly would be our vertical shift. Here the -1 tells us we're going to move every point down 1. So this point at 3, right on the x-axis, let me do this, get over here, is now down at 3, -1. These points here that were at a height of 2 now got knocked down to a height of 1. The x values did not change. And then the 8s got knocked down to 7. So I'm going to go over 1 more, up to 7. From here, over 1 more, up to 7. So there's our shifted and shrunken parabola. Okay, a couple to try on your own. Here's 8 and then 9. Ooh, and then that will be the end of this video. Okay, here is our function. I should have made that a little bit bigger. There we go. All right, order of operations. First, horizontal. We are going to move it left or right 1 unit. The plus means we're going to move it to the left. So all our x values get subtracted 1. So that -2 is now a -3. This 0 is now a -1. This 2 is now a 1. Come on. There we go. So I could connect those dots. And then this 4, -3 is now 3, -3. And this 6, 0 will be a 5, 0. So everything got moved to the left 1 unit. Next, stretches or shrinks. We have this 3rd out front. That means we're going to cut our y values into a 3rd or divide our y values by 3. So the x-intercepts will not change. 0 divided by 0 divided by 3 is still 0. So where the old graph touched the x-axis, so will the new ones, but the other y values get cut into a 3rd. Here's a height of 3. 3 divided by 3 is 1. So that is now -1, 1. This point over here was 3, -3. Divide that y value by -3. Now it's just -1. So everything got pulled closer to the x-axis. R, reflection. We put a negative out here, so that means it's the same thing as putting a negative in front of all our y values. All our y values will change sign. Again, the x-intercepts aren't going to change, but our y values will change sign. This was up here at a +1, now that's at a -1. This one down here was at a -1, now it's at a +1. So that reflected us over the x-axis. Finally, down 2. All those points are going to go down 2 units. Their y values will decrease by 2. So this -3 will now be down at -2. Same thing with 1 and 5. Those were the old x-intercepts. They're still on the same line down here, shifted down 2. This -1, -1 gets shifted down 2 to -3. And this +1 gets shifted down 2 to -1. So it looks like that whole graph is now under the x-axis. And the last one here, checkpoint 9. Let me do this. I'll get a couple of these ready to go, and then I'll just bounce back and forth between them. Get over there. Okay. First up, let's do some points on good old x squared. 0, 0, 1, 1, 2, 4, 3, 9. So it looks a little something like this. Left, right shift first. That's a -1, tells us we're going to move to the right 1 unit. So I'm going to go over 1 unit, and all the other points get knocked over to the right 1 unit. This point that was at -1, 1 is now our new y-intercept. Oops, I did not go far up enough there. There we go. Those are at a height of 4, and then these are just off the graph at 9. So there we've done our right shift 1 unit. Next up will be stretches and shrinks. And we've got that 2 in front out here, and that's just like taking all our y values and doubling them. So all y values get doubled. Here on the x-axis, y value is 0, that's still 0. But now if I go over to 2, this was at a height of 1, now it's up to a 2. Same here. These points were at a height of 4, now we're going to go up to 8. And then that will take us off the graph paper. So next up, reflections. I don't see any reflections, no negative signs to flip us over the x or the y-axis. So the last thing will be a shift up of 3 units. So here at 1 0, that is now up at 1 3. So this point here was 2 2, now it's 2 5. This point was 0 2, now it's 0 5. These points that were at the 8s got shifted up to 10, so I guess I can put them just a little bit up off the graph. And there's what our final shifted, stretched parabola would look like. And that's the end of the video. Homework is probably going to be a worksheet.